the record. And now you can minimize that control panel if you want, so it's not taking up so much of your desktop. You see the little the white arrow inside the little orange box?
Yeah.
That is a toggle switch. That will minimize it and maximize it. So,
oh, there we go. Just minimized it.
yeah, and you can leave it, and then you can even move that little tinier rectangle to the side if you like.
All right.
Okay.
Cool. Yeah, there we go. Now it's out of the way.
Now you're looking at my desktop, and I can write equations and so forth and so on, and then we solve them. And most of my students are usually able to verbalize the problems, and you verbalize it and I'll write it, and then we'll both solve it. And
okay.
that works pretty good. The only time that doesn't work is if you are given a graph to interpret. And
okay.
if you have problems like that you ever want to do, take a picture of it and send it to my email address.
All right. Yeah, I don't think there's any graphs on schedules that I have so far.
Okay, good. Why don't you pick some problems that you'd like to go over and verbalize them, and I'll write them, and we can try to solve them.
Okay, so tomorrow I have a quiz, and the teacher says it's just going to be a very short quiz, but she gave us like the 4 specific problems that it's going to be on.
Let's do it.
So if we could just go over maybe those 4, that'd be great.
Okay.
Okay, so here, it's in my notebook what they are.
Okay.
Okay, so here okay, so it's just going to be 4 problems, and the first problem is just to write the quadratic equation and say what it's used to find. So,
what is it?
X equals negative b plus or minus the square root of b squared minus 4ac all over 2a.
Did you do that from memory, or were you looking at it on paper?
No, I did that from memory. There's a little song that it goes.
Very good. Very good. That's a good thing to have memorized. Okay. And what do we use it for?
We use it for, is it for finding the x-intercepts from y0?
Yeah, that's well put. It's actually used for finding the zeros of a quadratic, any quadratic.
Oh.
It's not used for a cubic. It's not used for linear. It's only used when we have a quadratic that cannot be factored. In other words, if I gave you this quadratic, you can't factor that.
Mm-hmm.
There's no 2 factors that, in other words, I can't break that into an x minus 1 times an x plus 1.
Right.
So whenever you have a quadratic that you cannot factor, the only way to find the zeros are using the quadratic formula. And you're right, that is, I'm always setting y equal to 0 because that will allow you to find the x-intercepts. When you're on the x-axis, that's when y is equal to 0.
Okay.
Okay.
All right. And then, question 2 on the quiz, and this is kind of what we've been going over recently, is she's going to give us a factoring problem, and then we're going to have to factor it out.
Let's have it. Let's talk about factoring, because factoring is kind of everybody's bugaboo.
Yeah.
I have a little different technique than the one you may have been taught, so let's go through a problem and see.
Okay.
Do you have one? I can make one up if you like.
I mean, I've got some pretty simple ones.
That's all right.
But, like, here's an example she gave us, like, x squared minus 4x minus 12.
Okay.
And then we would have to factor that out.
Uh-huh.
So, all right.
So what's step 1 in factoring? First of all, let me ask you, at Kent, have they taught you anything called like the California method or the diamond method or anything?
Nope.
Good.
Maybe
I
not.
hate those methods. Those methods are the most
Okay.
complicated, confusing, and boy, when I have students that were taught the California method, it's just brutal for them.
Well, good. Glad we're on the right
Well,
track.
I have a method. I don't know what it's called, but it works very well.
Okay.
Let's just go through the steps. Step 1 is making sure that what goes there multiplies together to equal this term, x squared. So that would be x and x.
Okay.
Step 2. This is the one that everybody tends to want to forget. Step 2 is to figure out what these signs are, both of them. What must they be
Okay.
in this case?
Since they're both negative, like since it's a negative 4x and a negative 12, is one positive and one negative?
It is, but it's only based on that.
Okay.
Only based on the sign of the constant. Because whatever I put here and here has to multiply together to be equal to minus 12, which means these signs have to be opposite. Because only opposite signs will give you a negative. Okay? So that's step 2. Step 3 is factors of the constant, not minus 12, but factors of 12 that subtract, because of that negative sign right there, to the number 4. So what factors would that be? Here's factors of 12.
12, 6, and 2.
Which of those factors subtract to the number 4?
6 and 2.
Okay. Now we're going to take the bigger factor, 6, and put it with the sign of the middle term.
Oh, okay.
And now one last thing you always want to do is check the middle term. We don't need to check this term here. The way I constructed the factoring, I've checked that after step 1.
Right.
We also don't need to check this term here. The way I constructed the factoring, that's guaranteed to be minus 12 plus 2 times minus 6. So the only term we really need to check to make sure it's correct is the middle term. And you do that by multiplying the 2 inside terms and the 2 outside terms, and then adding the results together. That's 2x, that's minus 6x. Add that together, you get minus 4x. That's our middle term. We did it correctly.
Okay, that's a simple way to check.
Yes, it's a nice way to check. Okay, so now what are my solutions to this quadratic? Where are my zeros?
Your zeros are 2 negatives, or 2 comma 0 and negative 6 comma 0. If you're going to graph it.
Not quite. In other words, we have a rule in algebra that says that whenever we multiply two things together and we get 0, then one of those two things has to be 0. And even both of them can be 0. So the way I solve it from this point is I set that equal to 0 and I set that equal to 0. So x plus 2 equals 0 means that x equals minus 2. There's one solution. And x minus 6 equals 0 means x is equal to 6. So you were close. Basically, just change the sign, Change the sign.
Okay. See,
as long as it's a 1 in front of the x, then it's as simple as that.
Right.
Okay? Now, let me give you one and see if you can work through that exact same pattern on one. Step 1?
All right, so step 1 is to...
And, you know, I've never said this to anybody, but it might be worth writing down these steps.
Okay, yeah, I didn't write them down that first
That's
time. So I
okay.
think I'm gonna
That's
write 'em
okay.
down.
The only reason I suggest that is because invariably anybody that's been taught this thing called the California method always forgets step 2 when I give them my method. And if you forget step 2, it's awfully hard. It's hard to solve the whole quadratic in one bite. So having separate steps that you can just follow regularly is useful. So step 1 is what?
Step 1 is to make sure that we add up to the first, to like the x squared.
Okay, so what do I have
or like
to put
they
as
multiply x in both of them for the first
All
one.
right. Second step is what?
Second step is to make sure the signs are right.
Is to figure out both signs.
Okay.
What are they going to be? Based on the fact that it's a negative sign in front of the constant, what do the signs have to be?
They have to be one negative, one positive?
Yeah, and it doesn't matter because there's an x here, whether I put my minus sign here and my plus sign here, or vice versa. Okay. Now, there will be harder factoring problems where it will matter, and we'll get to those. But let's start with the easy ones. So we've done step 1 and step 2. Step 3 is what?
Step 3 is to find factors of the constant that can work out to equal...
That subtract because of that right there.
That subtract to equal the 3 in
Right,
front of the x.
not negative 3, but just 3.
Just
So
3.
what are factors of 10 that subtract to the number 3?
5 and 2.
Okay. We take the bigger of those factors and stick it with which sign?
The sign in front of the 3x.
Very good.
So the subtraction
You
sign.
may not have to write these down. You may get them the first time through. And that would be wonderful. So what are my solutions?
So then your solutions are going to be -2 and +5.
Okay, good. Let's do one more because
All right.
I want to cover a slightly different situation. Let's look at this one here.
Okay. Let me write that down.
There, I did step 1 for you.
All right.
What's step 2 going to tell us about the signs?
Step 2 is going to tell us that both of this, both the signs are going to be negative.
Yeah, they have to be the same. So they're either both negative or both positive, and just look to the middle term to figure out what. In other words,
that one of them has to be negative.
both of them have to be negative. In other words, the only way I can produce a +10 is if these signs are the same, either ++ or -–.
Right.
Okay, now step 3 is factors of 10 that do what? No longer subtract to 7,
but add to
7. Again, that's 5 and 2.
And then in that case, it doesn't matter if we put the 5 in the one on the left or the 5 in the one on the right.
Correct. Okay? So those are simple quadratics. And by simple, I mean they each have a 1 in front of the x squared term.
Right.
And it's only when that's the case that this rule 3 applies. In other words, let's change it slightly. Let's make it slightly more difficult. And let me see here what I'm going to need. Just a second. Now let's make that a 1. And Make that. What does that give me for a quadratic? That gives me 2x squared minus x plus 2x minus 1. So, if this is our problem, I'm going to erase that because you got it memorized anyway. So, now let's factor this. So now what goes here and here?
There's going to be 2x and then x.
Yeah. They still have to multiply to 2x squared. And you never want to do this. That is never a solution. Even though that multiplies to 2x squared, I want to split up the x's always. Okay? Just in case you're wondering. Okay, now we still have to figure out the signs. What are the signs got to be?
Negative. Okay, so since they're gonna have to be opposite.
Yes. Which in this case, now it matters whether it's plus minus or minus plus. Just take my word for it for a moment, and you'll see why it matters. So I allow for both possibilities. Now there's not a lot to try. Let's try one here and one here. Does that work? And try my double smiley faces method. In other words, you still don't have to check the front and last term, because all you have to check is the middle term. Does that produce a plus x?
So we would have one that does, no.
It does not, but it produces the right number, doesn't it? Just the wrong sign.
Yeah.
When you get the right number and the wrong sign, just move your one to the other one, and that'll be right.
Oh yeah, now it works out good.
Now it works good. And so there's a little bit of trial and error. The biggest difference is that the moment you have a coefficient in front of one of your x's, you've got to throw out rule 3. You can no longer say factors of 1 that subtract to the number 1. That doesn't apply anymore.
Okay.
It becomes trial and error. Not a lot of trial and error, but some trial and error. And it's hard to escape trial and error when you're factoring quadratics. Even with the California method, there's a bit of trial and error needed, where you have to write out, you just have to try various factors. Hopefully you don't get a problem like this. Because there are massive possibilities of combinations there.
Right.
In other words, it could be 4x times 3x, it could be 6x times 2x, it could be 6 times 4, 12 times 2, 8 times 3. In other words, they're not going to give you a problem like that.
Hopefully not.
But I don't think so, because it just would take too long. In other words, they might give you a problem like that, but that might take 20 minutes to do just because there's so many different combinations.
Okay.
And so they wouldn't be able to give you very many of them. But that, in a nutshell, is factoring. It's really easy when it's a problem like this, and it becomes steadily more difficult the greater the numbers are. In other words, even that might be tough, because I can be 4 and 1, I can be 2 and 2, I can be 4 and 1 or 2 and 2. So there's quite a bit of possible solutions to try.
Okay. There's one more here that we did for homework that I did not understand, because it's kind of complex, I think. But here it is. So parentheses 9x minus 5 close parentheses 8x plus 3 parentheses 9x minus 5 close parentheses.
Okay. Your whole life you've factored out monomial terms, right?
Mm-hmm.
Single terms only. You can factor out binomial terms. In other words, all factoring is dividing both terms by a number. So notice that there's a 9x minus 5 there and a 9x minus 5 there. Let's factor out a 9x minus 5. What is left? Now remember, when you factor, all you do is you divide that term by the factor. So what's left?
Okay. Oh, so we're dividing that term. So then it's going to be 8x.
Right. And now do the same thing for that term.
Oh, plus 3.
Exactly. It's as straightforward as that.
Okay, because that looked really scary when I tried to do it last night for homework.
It's really useful when you have cubics that can be grouped. I don't know if you've ever done those.
I don't think so.
When you have a cubic that you can solve by grouping, it always ends up where you factor out a binomial term. And you're usually left with some sort of a binomial term. Okay. But is there a fourth problem that you want to look at? Have we done 3 of the 4 that you said?
Here it says there's 2 more that she has down here.
Okay, let's look.
So like for number 3, she says solve. So find x when y is 0, and then that's very straightforward. That's just plugging it into the quadratic equation.
Okay.
Like
Yeah. If you cannot factor it, which most quadratics you really can't factor. It's only special constructed ones that factor easily. But the typical quadratic needs to be solved by plugging it into the quadratic formula.
Okay.
But it's always worth a shot at trying to factor it because it's easier. I mean, plugging it into the quadratic formula is just a lot of math, a lot of arithmetic. So if you can factor it, it usually saves you quite a bit of work.
Right. So I think I'm good for those. But then the fourth problem is solving by completing the square.
Okay, let's do one of those.
We did a little bit of that on the first time we met, but I'm still a little confused by those. So here's an example she gave us. So she says, solve by completing the square for x squared minus 5x plus 7 equals 0.
Notice that I cannot factor that. There are no factors of 7 that add to the number 5. That would be step 3 if I tried to factor it, right? I'd be looking for factors of 7 that add to the number 5. They don't exist. So I got 2 choices here. I can plug into the quadratic formula, but the quadratic formula actually came from completing the square. When you complete the square, best thing to do is to move the number on the other side, which is confusing to a lot of people because they wanted to put that number on the other side in the first place.
Yeah.
That's usually the biggest mistake people make, is to put that number on the right side and then try to solve it by factoring out an x. That doesn't work. But there is something that works. I can complete the square. You can complete the square whenever you have an x squared and an x term. Now, the goal of completing the square is so that I can write it as some x minus h quantity squared. If I can get it to this, then I can solve it pretty easily. I'll show you how. Now, the rules for completing the square, do you remember what they are?
It's like, I think like one of them was like
take half
half
of that number and then square it.
Oh, okay. Yeah, half. Yeah, 1/2. So 1/2 5 squared.
So 2.5 squared is 6.25, I think.
Mm-hmm.
So I'm going to add 6.25 there. Of course, because I add it there, I got to add it over here,
Right.
because otherwise I would change my equation. But now notice that I have exactly what I started with. I have not done anything. As all I did was I moved the 7 to the other side, and then I added 6.25 to both sides. Okay? Now, the beauty is that because I completed the square, I can write this as x minus that 2.5 squared. Because I completed the square, this is writable this way. Well, the other side of the equation becomes minus 0.75. I add both numbers together. With me?
Yep.
Now I can solve it by taking the square root of both sides. So,
Oh, yeah, because...
yeah.
Okay.
So if I take the square root of the left, I get that. What do I get when I take the square root of the right?
You get an imaginary number? Because it's negative?
But most importantly, whenever you take the square root of both sides of an equation, always start your answer out with plus or minus. And I wish I could turn that into a song like they do the quadratic formula, because everybody forgets the plus or minus. So it's plus or minus the square root of 3/4, of negative 3/4. So
yeah, I would have gone right past the plus or minus.
Well, just try to get into the habit of whenever you're solving an equation by taking the square root of both sides, your answer is always going to start out plus or minus. So now I can solve it. I just have to add 2.5 to both sides. So the answer becomes 2.5 plus or minus the square root of minus 3/4. Now, let's talk about how we can simplify that. The square root of minus 3/4. You must have had imaginary numbers to get this problem.
Just a little bit. But not much.
Okay, well,
yeah.
Most important thing is that I is equal to the square root of minus 1.
Okay.
Which means I can turn this thing into the square root of minus 1 times the positive square root of 3/4.
Okay.
That's the step you always want to do. Whenever you're taking the square root of a negative number, always factor that negative number into a minus 1 times a positive number. Because now I can replace the minus 1 with I.
Oh, yeah.
And the square root of 3/4 is the square root of 3 over the square root of 4, which is I times the square root of 3 over 2.
Yeah, so now it's all simplified.
Yeah, so now my final answer for x is 2.5 plus or minus root 3 over 2i. And that's the more typical way of writing it, is with the I after the coefficient. Like this. And it's worth knowing also that that means 2.5 plus root 3 over 2i, and the second answer is 2.5 minus root 3 over 2i. In other words, imaginary solutions always come in pairs like this. If you get one solution, you automatically know the second solution is this minus the imaginary part.
Right.
And so those are the two solutions.
Yeah.
So what is the square root of minus 36 equal to?
The square root of minus 36 is going to be equal to Okay, so square root of -1
Correct.
times the square root of 36.
Okay, so what's that?
That's going to be, oh, because then we can separate that again, right?
Well, no. In other words,
No?
well, you
So
only
this-
need to separate it once.
Okay.
Because this turns into 6, that turns into I.
Oh, so we just get 6i.
Get 6I.
Oh, yeah, I was trying to, because, okay, I was confusing it with the one that had the fractions. I was trying to
Well,
put, like,
it's
6 over.
unfortunate that they gave you such a complicated one in this
Yeah.
the square. It's not very often. Usually when they start you out with completing the square, they don't give you fractions like this. But this was actually a particularly easy fraction to take the square root of because the 4 is a perfect square. And it's in the denominator, so you end up with a fully rationalized coefficient.
Mm-hmm. So that worked out well.
Yeah. All right.
All right.
Got any last questions, Casey?
Nope, I think I'm set for tomorrow.
Okay, well, good luck. And
Thank you.
let's see. I have recorded this, so let's see.